Welcome to the TechArena, featuring authentic discussions between tech's leading innovators and our host, Allyson Klein. Now, let's step into the arena.
Welcome to the TechArena. My name's Allyson Klein, and today we're coming from Mobile World Congress in Barcelona, and I'm so delighted to be joined by Dr. Christophe Bianchi, Chief Technologist for Ansys. Welcome to the program.
Thank you. Thank you, Tom.
So why don't we just start? Ansys has never been on the TechArena before. Why don't you just start with an introduction of the company and your role?
Yes, and actually also the first time we were at Mobile World Congress, so we are going to cover that. Ansys is a company that's been in business for more than 50 years, and we specialize in just one thing. We do engineering simulation. What we do is convert the law of physics into program to help designers in all industries create a product. Mm-hmm. That's what we've been doing, and it's covering multiple aspects of physics, from aerodynamics to electromagnetic wave propagation, which is very specific to what we see here at Mobile World Congress. But we cater to the automotive industry, we cater to the aerospace and defense, and of course to what we call the high-tech industry, which is semiconductor and intelligent connectivity. My role in the company, I'm Chief Technologist. I report to our CTO. The way we are organized is by industry. So my focus is on high-tech. That doesn't mean that everything else is low-tech, but it's really where most of the electronic intelligence is built into products and products. I'm based in the south of France, but I cover our customers worldwide. And the role of the CTO office is to work ahead of the curve. So we are working with engineering department, R&D departments, and our customers, which means that the product we're helping them build will hit the market in 2 to 3 years. The role of the CTO office is anticipate the next wave of demand. So we're working on the 2 or 3 year horizon of our solutions to product that will hit the market in 6-7 years.
Mm-hmm. I'm very familiar with Ansys in your role in high performance computing and being one of the largest workloads in terms of compute performance with my background in semiconductors. But your name was new to me from a standpoint of Mobile World Congress. And I guess one place that I want to ask is, how do you approach simulation and design acceleration for the communication arena? And what are the opportunities there?
So, And that's probably known only to the engineers today. We're a well-kept secret, not by design, but that's the way we're really too shy. I don't know. When it comes to electromagnetic simulation, radio frequency propagation, we've been the gold standard for many years. We have solutions. The brand name is called HFSS. Every designer building antennas, base stations, communication systems in all different wavelengths and bands is using an Ansys tool. So if you look at the companies present at Mobile World Congress, all the companies building equipments are users of Ansys. But until very recently, we only focused on the equipment, the components level. We made we spent a lot of effort in developing solutions that address the entire communication system, from what we call the nanometer to the kilometer. So being able to model antennas, phased array antenna, base stations, tower systems, radomes, but also putting this into a city and modeling the communication from tower to tower to subscriber to satellites. And this is what we're showcasing to our customers today. So moving really from the component to the system of systems. Until very recently, it was inconceivable and unfeasible to have the level of accuracy that we provide in our solution, which is true to physics, electromagnetic simulation, at the system level. And it took us to acquisition, years of R&D, dedicated hardware working on GPUs to run our software, to be able to deliver what we're presenting this year at Mobile World Congress, which is called an entire channel modeler, the ability to run real-time simulation of a full digital twin of a complete 5G operating system, 5G network, modeling all the channels all together, all the signals at the same frame per second, which then runs actually like to the point that we can even connect this API to our software to hardware tester or 5G tester. And this is unlocking a lot of new use cases for simulation, for digital twins. And it's becoming essential because when we see in the recent evolution of 5G and then the upcoming 6G is the demand for more customization, more use case, more ability to do software-defined everything, whether it's software-defined satellite, like conversation we had this morning, or software-defined communication system, software-defined vehicle. All of these are the components of reprogrammability while the product is operating. And for that to do that in a predictable fashion and obtain the benefits both in reliability, safety, performance, the concept of adding a simulation elements or digital twin is essential. That's what we're introducing and launching this year in Mobile World Congress.
Now, when you were talking, one of the things that I was thinking about is the conversations from operators on the expense of truck rolls and the expense, especially when you consider the broad span of networks and what you were just describing in terms of being able to see that entire picture. Can you talk a little bit about how simulation has impacted your customer base and where are the gains that they see? Is it time? Is it money? Is it, is it ultimate solution performance, or is it all of it?
It's a combination of different KPIs or different metrics. But if I look at just at the component level, when we interface with our customers on simple problem like developing a passive antenna, through simulation you can reduce the number of prototype cycles and have the right first time results. That's not only time and money, but it's also opportunity costs. So we've seen reduction in the order of 10x in the development cycle when we implement a full suite of simulation. So basically creating the entire antenna in the virtual world, qualifying it before you start to build the first physical element. And that goes with not just the antenna system, but the complete our base station or the complete network infrastructure. So it's simulation is a way to reduce costs by reducing the amount of physical prototypes. It's also reducing, of course, the design time in orders of magnitude. But because of that, because of being in the virtual world, you actually unlock much more creativity from a design standpoint, and allow the designer to explore much broader design spaces. And when you apply that to network planning, for instance, if you have the ability to simulate the performance of your network in a given city, like you upload a very precise map of the city of Detroit, which is one of the example we're running here, with 5 centimeter level accuracy, you can have all the KPI analysis and all the performance of the network and decide what to put antennas in base station. So optimizing the setting of your network is also a cost for the operator because it's going to have the right performance and the right fit between what the system provider is going to bring to the operator.
And we're at Mobile World Congress, so I've got to ask, everybody in the hallways is talking about broad proliferation of 5G. Are we seeing a downturn in 5G infrastructure deployments? The upcoming 6G specs, and are we seeing a turn to starting to develop 6G solutions? How do you see that evolving, and why do you feel like there's this interplay between 5G and 6G right now?
So what we see, and again, it's from the very, very small view of the world, which is working with our first of all, 5G is deployed but not really utilized. If you look at the average usage of the millimeter wave sections or the frequency section of the 5G network, it's very small. It's around 10%. And these are use cases that are currently not implemented, but these are high-value use cases. So working on these use cases require also a continuous development and improvement of the installed hardware. When these new use models will be deployed, dynamic slicing, everything that has to do with providing more value and more customization on a subscriber level of the quality of service, that continues to require a lot of engineering effort and deployment. It's not just in the software side; it's really at the interface of the software running on this network system and the hardware. This is where exploring a use case, exploring how far we can push 5G is a place where simulation is really critical. 6G, it's a little bit more than research now. We start to see systems that we are testing. We're moving in a completely different world because the frequencies are very different, much higher. But also the reconfigurability, the ability to dynamically reconfigure the constellation to optimize the traffic on these frequencies is extremely complicated. And again, having an accurate way of modeling that ahead of time is important. So 6G has to my knowledge, a slightly different use mode in 5G. It doesn't address the same needs.
Right.
And it's definitely not for the general deployment, just the way 5G is. And even in 5G, working down the aisles of the Mobile World Congress, which I had time to do as much as I wanted, because I was stuck in the but it's really, you hear a lot about private network versus public networks, so applications that are really dedicated to one particular industry, 4.0 that we talked about. We've seen application in the healthcare sector where you really want to control the quality of service. So we're going to continue to explore more use cases of 5G. Well, I think for the next decade, it's still going to be the main dominant thing. And 6G will pick up additional use cases.
Now, no interview would be complete in 2024 without a mention of AI. And I know Ansys has put the technology into practice in a lot of your solutions. How is it forming your decision-making around technology choices? And where can you point to examples of how AI has really transformed what you're able to do for your customers?
So besides the very popular large language model, ChatGPT type of function, which is basically a replacement of the traditional user's manual, where they just query with natural language, that every company does that. For us, AI is way more than this. There are basically two aspects of AI in our offering and the way we interact with our customers. There's the hidden part, which is using AI as a way to make our product provide better results and faster results. So using machine learning, coding techniques to improve our generic solvers and our specific solvers. That's been practiced in our engineering department for the past decade. So we have today close to 95% of our software that has, to some extent, a portion of AI built in. The second part is how do we use AI to enable more design productivity to our customers? I usually take a very, very simple example. Simulation just is a way to virtualize your design environment. It tells you what a given design will look like. And a good engineer can, if you give a design with three type of parameters you can option. So you're in 3 dimensions. We can visualize where the optimum solution will be. Good engineers can probably think in 6 dimensions. Nobel Prize probably in 7 or 9. But today the parameters that dictate what a 5G network looks like are hundreds.
Right.
There's absolutely no way we can visualize or interpret or come up with the optimal configuration for a given product. And naturally, without machine learning and AI, the way to do that is you simplify the problem by just restricting your design space to by fixing some of the parameters and exploring just a few. What AI does, it unlocks all these dimensions. So with AI-powered solutions, and we have multiple flows that give access to these AI technologies to our customers, you have the ability to explore all potential options for new or for improvement of a design. There's also a second element which is essential, is AI is, when we talk about AI in our space, it's a lot about machine learning. And machine learning, there's learning in it, so it needs a lot of data. But in our space, data is simulation data, and our customers, they're not new to electromagnetic simulation. They've done that for decades.
Sure.
So they are sitting on their shelves huge assets that are catching dust, which are simulation results of previous generation. This is a gold mine for machine learning. And what we've done is we introduced methodology and solution that actually turn these dormant assets into IP, which is the customer IP. There's savoir-faire. That we really take as an input to provide response models that will guide the designers into improving or creating new solutions. The data is captive to the customer. We don't look at the data. That's the customer data. That's the number one principle in AI, is customers' data is kept by the customer. But we provide solution methods so they can turn these dormant assets into value.
Very nice. Now we're at MWC. I've got to ask you, you've been in a lot of industry conversations. It sounds like your team never stops with industry conversations. What are the highlights from others in the industry about what's happening at MWC this year, and what are you most excited about?
Oh, so I'm excited. Well, the excitement comes from the realization that there's more use case than just the regular use of our cell phone on the network. We're working in many industries. One of the industries that is evolving extremely fast is automotive. Automotive, if you look at level 4 autonomy, we all know that it's not going to happen without V2X and V2V. That requires infrastructure. For a car to drive itself autonomously in a city, there has to be a 5G network. How do we bring these two worlds together? Because it used to be that in engineering, whether it's a semiconductor, my alma mater that you know very well, or other, in last decade, you would give a specification to the designer, and it would design the product to spec, and then the job would be finished. Today, the spec is the system. And if the system is multiple cars driving together autonomously, that's the spec. How do we help facilitate this conversation is what everyone is trying to solve here. And we see very interesting solution in transportation with drones, with autonomous driving. Industrial IoT is now catching up, and that requires a lot of simulation. So we have a job for generations of that.
A lot of complicated simulation.
Yes.
That's fantastic. It seems like AI and some of those new techniques are coming at exactly the right time.
Yes, for us and for our customers. And we see very impressive AI use cases in the private section of the demo of some of our top customers. I can't name them, but I still trying to figure out and understand exactly the magic they were presenting to me. So I'm a geek. I love technology.
Yes.
This is a place to be.
That's fantastic. One final question for you, Christophe. Where can folks find out more about Ansys and the solutions you talked about today? So, of course, on our website, there's a lot of information. They can reach out to us through all the social network. You have my coordinates. I'm happy to talk about the future of technology in all industries, and in particular in high-tech and telecommunication. Thank you so much for spending 30 minutes of your time with me. I know your time is precious this week. Thank you. Thank you so much.
Welcome to the TechArena, featuring authentic discussions between tech's leading innovators and our host, Allyson Klein. Now, let's step into the arena.